Hello students, now we are going to start static or kinetic friction. This topic is from law of motions. Let's begin the topic. Static friction and kinetic friction. So one by one we are taking this. First, what is the meaning of static friction? It is equal to applied the force in magnitude. Okay, means if we are taking a box and both side force is applied, I'm supposing this is a F1 force, F2 force is applied, and both are equal in nature. That means F1 is equals to F2. Is the body will be start to move? No. The answer will be body will be remains static. That's why we are saying this one as a static friction. Whereas if I'm taking this box again and that both side I'm just trying to apply force like F1 and F2. And among of this F1 and F2, may F1 is greater than F2 or F2 is greater than F1. Okay, so it is equal the applied force in the magnitude only when it is sliding in the constant velocity. Okay, see, this will be only applicable if this will be a sliding body. Okay, because if this will be a sliding, there will be one extra forces involved with that, which is mg sine theta. Because of that body start to move. Okay, but in the case of like a linear terms, there are two forces. Among two forces there only must be equal. Okay, opposite to the applied force in the direction. Okay, and in this way always opposite, okay, to the direction of velocity of the sliding. If we are taking the kinetic friction like a static friction, they are of course they are opposite, and in the case of a kinetic friction again they are opposite in the nature always, but one of the force magnitude must be equal, must be greater than in the case of a linear. Again, if the body will be in the slant like sliding or rolling like that, so if the force is equal, one extra component will be added, which is mg sine theta. Okay, so one thing is I think you are capable like sliding friction is less than, okay, static friction. What is the mean of that? See, friction is what? Friction is something opposition offered by the surface. Okay, so if the body is static, means is in a rest, that means opposition is more. Opposition offered by the surface is more. Understood? But if the body start to move, that means they not have enough, not have, okay, enough, okay, enough friction to stop the body. Understood? So who have more, which can comes to the body as a rest. Okay, so static friction, that's why is a more than sliding friction. I hope there is a no issue in that one. So now moving with some multiple choice question. Kinetic friction is always opposite in the direction of velocity of sliding. In the opposite to the direction, in the opposite to the applied force in the direction, it is equal to the applied force in the magnitude. None of these. The correct answer is always opposite in the direction of velocity of sliding. Okay, like this. Static friction, it is equals to the applied force in the magnitude. Kinetic, it is equal to the applied force in the magnitude only. The second one is opposite to the applied force, okay, in the direction, and the kinetic will be, it is always opposite in the direction. Okay, so it will be always opposite in the direction when the body is sliding. Always remember when the body is sliding. Okay, next, sliding friction is always less than static friction. Rolling friction, dynamic friction, none of these. I hope you know the answer. Yes, the correct answer will be static friction. Rolling friction. Rolling friction is the what? The force of friction comes into play when a body rolls over the surface of another body. Means if I'm taking a slant body, inclined body, so if the surface is smooth, body start to slip, okay, but the surface is a more as a rough, the body start to roll, okay, like a wheel is a rolling. Clear? Because of the friction, our planets will be revolving. So all these kind of a thing occur because of the friction. I hope this will be clear, student. If you have any kind of a doubt, you may just ask in the comment section, okay? So it is always easier to roll than a slide a body over another body. In this concept, we are using a trolley bags, and trolley bags, what we are doing, like we are not holding the our luggage, we are just sliding our luggage, okay? So it will be always to roll or to slide a body over another body, okay? Like as you can see, this is a child which pull a suitcase. If the suitcase have a wheel, it can be easily done, okay, because of the friction. But if the friction is less, the body start to slip, okay. So the person also can slip. So sufficient kind of friction must be able for the rolling and for the moving of the person also. As you can see over here, the force of friction is opposite in the direction of motion. Okay, this is the direction of motion. It is convenient to pull a luggage on a roller, then carry it. Okay, so roller reduce the friction. The force of friction between the rolling of the body and surface is called a rolling friction. For example, like as you can see, trains are moving, okay, and the cart is loading by the person. As you can see, the fan is moving or rolling. So what we are doing, what they are actually doing, they are just rolling, okay, and this always all have thing happen because of the friction only. We can again take the case of a ball bearing, by which we can reduce the friction also and the efficiency of the machines also. So sliders are replaced in the most of the machines by roller using ball bearings. Okay. When a spherical body rolls on a horizontal surface, then speed of the body goes decreasing and finally it stops. The opposing force acting between the surface of the spherical body and the horizontal surface is named as a rolling friction. As you can see, uh, if I'm taking as a card, okay, and by applying some force, the card is actually start to move. But because of the friction, okay, that actual movement it will be not occur. The necessary condition to roll the center of a mass or to roll at the constant speed on an enough surface is that there should be component of the applied force parallel to the surface. This force component is numerically equal to the rolling friction like Fr. This rolling friction is slightly, okay, this rolling friction is slightly less than kinetic friction and which is less than the static friction. Okay, so the necessary condition for roll the center of a mass, like if I'm just taking a body which is start to rolling, okay, about their center of mass, they have a constant speed on a rough surface. Okay, there should be a component, okay, applied force on the parallel to the surface. So static friction is always greater than kinetic friction than a rolling friction. Thus, if I'm taking a kinetic, the relationship between kinetic friction and rolling friction, so kinetic friction is greater than the rolling friction. But in the case of a static, so the static friction is again greater than the rolling friction. Now move on the some multiple choice question. In the order of the friction is always, so as we know, static friction is always greater. Okay, so here it is in a like less, so this is wrong. Here it will be as a greater, but rolling friction, as you can see, rolling friction also greater, which will not be possible. Equal, not possible. So the first option will be correct answer. Okay. Rolling friction is equal to static friction, greater than static friction, less than static friction, or none of these. The correct answer is less than static friction. As you can see, rolling friction is slightly less than kinetic friction and less than static friction. So who have a more, static friction is more frictionable. Rollers are dash frictions increase, add, reduce, or none of these. What they are doing, they are just reduce the friction. Okay. Normal reaction force. So the force which are exerted, okay, means which are applies only when two bodies are in the contact. Okay, keep things in mind. When two bodies are in the contact, then only contact force we are saying applied. These force satisfied Newton's third law of motion. What is the Newton's third law of motion? Action and reaction. We can say action and reaction. Whenever any body occur any action, there will be always equal and opposite reaction occur with that. It depends only the nature of a contact. Okay, like if I'm just taking a body like A and B, they both are in the contact. So the nature of the body A, the nature of the body B is how is actually like which is the following, which type of a nature is the following A and B. These kind of applicable in both the section scenarios, but not the area of the contact. Okay, they are just taking the nature, not area, like how much. If the body A will be like this, body B will be like this, so it not like this will be big in the shape and size, not like that, and not depends on the area or volume. It depends only the nature of the contact, whether they are same materials or not, whether they are different materials or not, like this. The component of the force normal to the surface is called as the normal reaction. Okay, as you can see. So normal force is or normal reaction is always balanced by the weight mg. That means we can say R is equals to mg or R minus mg is equals to 0. Is there any doubt? If so, you can ask in the chat session. In general, all the surfaces are rough at microscopic level. The actual point, okay, of a contact. Actual point means where the point attach. Are difficult to ascertain. Hence, it's difficult. Okay, it's a problematic to know what is the magnitude and direction of these contact forces. Means if we are just sliding one bodies to another over, so there will be a external force, and this will be frictional force applying in the opposite direction. So it is difficult actually, like what direction we will take in the contact forces. So the resultant forces we are taking, like if the resultant forces by the result, because of this resultant force we can see if the bodies are moving, okay, that must have direction in the direction of a movement, and the direction of a force exactly we can say which one has a greater. So this we can see by this, like let us consider a block of mass small m. Okay, as you can see in this diagram, this is a block whose small mass m is, okay, resting on the surface, means simply it will be kept as the surface. Okay, as you can see, the surface is a kind of a rough surface. The center of gravity will be applying it in the form of weight. Weight will be mg, which is balanced by the normal force or a normal, okay, we are saying as a reaction So weight of the block is mg act vertically downward. Due to this contacts, the various point of the surface, resultant contact force act on the body. Clear? Let vertical component of the resultant contact will be N. So as the body has no vertical motion, okay, this component of the contact force N must be balanced. Okay, if the body is there is a no like external forces applied, so the body will be remains balanced. And that time, as I told you, R is equals to mg, or we can say N minus mg is equals to 0. This situation may occur. Since perpendicular to the plane of the contact, this is called as a normal reaction. So normal reaction is a what? Normal reaction is a resultant contact force acting on a body placed on the rigid surface perpendicular to the plane of contact. Clear? Normal reaction. So normal reaction depends on the nature of the contact. Okay, like what is the nature of the contact actually is? It depends on the area of a contact. Even in the event of the motion of the body on the surface, this force remains unaltered. Means this will be not change. It do not depends on the area of the contact. As I told you, it depends only the nature of the material, nature of the contact. Even in the event is in the motion or not. Okay, on the surface of the body remain altered. Okay, means unchanged. So in this case, the body resting, okay, means that this will be in the rest on a plane surface inclined at an angle theta with the horizontal as shown in this diagram. Okay, as you can see, if the body is placed on the inclined plane, making an angle theta with this, okay. So weight will be applied here. There will be two component of the weighted, like in the direction of a theta, this will be mg cos theta. In the perpendicular direction of a theta, this will be mg sin theta. Okay. If there you have problem like how I taken with the sin theta and the cos theta, so the diagram look like this. Okay, we know that this angle will be, we are taking this angle will be as a theta. Okay, this angle will be as a theta. Here I am assuming this will be perpendicular mg. Okay, this I don't know. So sin theta is equals to perpendicular upon hypotenuse, perpendicular mg. Okay, mg hypotenuse h. So sorry, h by this will be h mg. Okay, so this will be what? H mg. So h will be what? Mg sin theta. This will be the case of a hypotenuse, like mg sin theta. This will be the this will be showing as a case of a hypotenuse. I hope you understood. What you have to prepare, like in the direction of a theta, this component will be cos theta. In the opposite direction or perpendicular direction of a theta, this will be mg sin theta. The weight mg acts on the body vertically downward. Okay, as we can see mg, which is nothing but a weight component of mg cos theta perpendicular and plane existing with a constant pressure. The normal reaction given by n mg cos theta. See, n is balanced by mg cos theta. N is balanced by what? Mg. N is balanced by mg cos theta. So we can say like n minus mg cos theta is equals to 0. Now move with the some multiple choice question. A body lies on the table. Its weight is balanced by friction, normal force cause the motion of the body. Surface of the table. The correct answer is a normal force. Second question, normal reaction is a dash to the tangent on to the surface at the point of a contact. Parallel, perpendicular, equal, none of these. The correct answer is a perpendicular. So student, this is all much about for today's class. I hope you enjoy the session. If there is any question, any doubt, you may ask in the chat session. Till that, take care everyone.